It includes standard libraries, standard input output libraries. You can include in your in your C programming file, right? So the same way, if you import CV2, all the functionalities of OpenCV, they are available to you. Okay, and I'm again getting this matplotlib.pyplot as PLT. Okay, and I'm using this img is equal to CV2. CV2 is a package name, and imread is a function which is there in the CV2 package. So if I want to access the function within the CV2 package, I'm using this dot operator. Okay, CV2 dot imread. Okay, I just give the file name. Okay, file name first. Okay, and then I give this parameter 0 to ensure that I'm reading in a grayscale mode. Okay, I just want to show the grayscale mode. And I'm not using cv2.imshow because cv2.imshow is disabled. There are some other alternative ways, but I just want to show the how to use one function from one image processing function from one library and one package, and how to use the same variable in a different package as well. Okay, so I'm using the print img. Okay, if I use print img, it gets displayed a list of numbers. If you see, this is a matrix. It's a single 2D matrix. Okay, this single 2D matrix is the list all the intensities. Okay, corresponding to this cameraman image. Okay, cameraman image is a very popular image processing image. Okay, and which you can use it for your experimentation purpose. Okay, I'm using plt.imshow img comma cmap is equal to gray. Okay, PLT is a library here. Okay, there's a function called imshow which you can use to display this image. Okay, grayscale images values are between 0 to 255, and I have a grayscale image. This is not a black and white. Okay, now next see how to read a color image. Okay, you just don't provide the 0 parameter here. Okay, you just use cv2.imread mandrill.png. Okay, this is very simple, right? So it's very simple, and it's the same as MATLAB only. Okay, but the most advantage with Python here is you don't need an official license. Okay, Python is an open source, and you can work it from your own this thing. Okay, in your own laptop you can still install an IDE and then work out. Okay, and right, so plt.imshow of img, it displays the image. And I am also printing print of img.shape. Okay, I'm just printing the shape. If you see, it's a 3-dimensional matrix. Okay, this indicates the number of rows. This indicates the number of columns. Okay, this indicates the number of channels. You have red, green, and blue. That is how you represent your color image. Okay, so now if you see here, this is the image that is getting displayed. Okay, but the small correction you have to do. This is the actual mandrill image. Okay, but you got a displayed image like this. Okay, so what is happening here is, okay, when you are reading an image using imread function in CV2 OpenCV package, okay, it will interpret. So this img is a 3-dimensional matrix. The first component it will interpret as the first component it will interpret as blue. The second component it interprets as green, and the third component it's interpreted as red. Okay, but PLT, the imshow function in PLT assumes that the first component in img represents the red, and the second component in img is represented green, and the third component is blue. Okay, so the red and blue components are interchanged in most of the functions. So OpenCV has a different interpretation, and the other functionalities, the other libraries have a different function. You need to read the individual documentations as such. Okay, just because imshow is there in CV2 and imshow is there in matplotlib, that doesn't work. You have to start reading the documentation and understand. So that is the reason I wanted to include both these things separately. And now I will use the separate color transformation function. Okay, there is a function called CV2 color, CVT color. Okay, which takes img as an input and cv2.color underscore bgr to RGB. It converts and reads as img variable. Okay, and plt.imshow of img. Okay, it displays the color image. Okay, and displays the image shape as well. Right. So now this is the actual color image. Now what happens here is I'm passing this. Right, so there you have several color spaces, RGB, HSV, LAB. right? So between all those color spaces, if you want to do transformations, this is the function that you have to use. Okay. So if you ask me, do I remember? No. Okay. What do I do? I'll take the help of Google. Okay, you will not remember it all. Okay, but I know that color transformations have to be done. Okay, but what should then? What is the next thing I do? Open CV color transformation. Open CV color transform. It displays color conversions, CVT color. It actually displays. And OpenCV is there in C++, C as well as Python. So I use Python. Okay, so to get the information about color conversion. I will not remember all these things, but I know that I need to do color conversions. Okay, so you should not remember all these things. If it comes by practice, okay, if you practice more number of times and you get remember like this, you will, that is the way you should remember. But however, if you are specifically spending time to remember them, it doesn't make sense. Okay, here if you see there's a warning already coming. You are connected to a GP environment, but you are not using it. Okay, this is not acceptable. Okay, so what you need to do over here is you need to change the runtime time. Okay, you have to just keep none so that the GPU is not getting used. Okay, when I change the runtime time, it will restart again. Okay, so you have to link the Google Drive again to this Colab environment and start working. Okay, so let me start with a small demo called optical character recognition. Okay, so optical. So what is optical character recognition? Let me go back to this image. Okay, so the image is nothing but a matrix of values. Okay, and suppose say there is a small text which is written here. Okay, there is a small text which is written here, and this text itself, individual pixel elements will be read as values only, intensity values only. Okay, so given this set of numbers, a collection of numbers arranged in a specified pattern, how do I infer the textual information embedded within these numbers? How do I infer the textual information embedded within these numbers? Okay, is what is all about OCR, optical character recognition. Okay, OCR system transforms the 2D image of text that could contain a machine printed or handwritten text from its image representation into machine readable text. Okay, so the OCR is extremely useful for automated text entry into computerized systems. Okay, so you want to enter these systems automatically, then that can be used. Several challenges exist in digitizing the documents. Let's see some of the applications first before getting into the challenges. You want to build an applications of license plate readers. Okay, suppose say these days, what's happening with policemen, if somebody is violating the rules and regulations here in Bangalore, what they do here is they use a point and shoot cameras. Okay, and then if the vehicle is not reachable, then what's the best thing that he will do is he'll use a point and shoot camera within his hand, and then he'll capture images. Okay, of all the people who are violating the traffic rules and regulations. Okay, now the task here is to build an application to identify the license plate information automatically. You want to extract the license plate number. Given an image, how to extract the license plate number is what is the one of the tasks given to you now. Okay, so the next thing that you have to do here is when you are, see, there are several objects and you have a text information related to it. Okay, text information on the license plate. There are several cars and everything. Okay, among these multiple elements that are there in your image, so how do you actually get to the textual element is what is the feature extraction block, which I was showing here in the first step. Okay, and region of interest as well. Okay, so now once you do identify the license plate information, okay, what's the next thing that you have to do? You have to identify the individual characters. Okay, whether it's AP13N9941 is my bike's license plate number. Okay, so if I have to identify the individual letters also, A, P, all these alphabets and numericals have to be identified. That comes under region of interest identification and inference as well. Okay, so that is what is OCR. That is where OCR can be useful. Okay. And digitizing invoices. Somebody wants, suppose say a businessman, a traditional businessman has thousands and thousands of bill books lying around, and then he wants to get rid of all those bill books and convert them into digital. He want to digitize all of them. The best thing he can do is he can take a snapshot and then he can write. He can use a small software program which can understand the tabular columns of various elements of the bill book. Okay, of every bill, and then it should have the intelligence to infer the text written with handwritten English, because handwritten, the most olden days the handwritten bill books are only used. So digitizing menus, okay, digitizing. If you are going into a restaurant, suppose say you're going to a foreign country, you are unable to understand the restaurant menu. Okay, the best thing that you can do is you can take out the Google Translate app and take a snapshot and then feed it to the Google Translate app. It will tell you all the menu elements converted into English.
Hello and welcome
For
back
which
to another map.
your Translate app should have that intelligence, right? Okay. So if you want to do that, you have to digitize those menus and you try to train your system in order to recognize the text written in the menus. Okay. So these are some of the applications of OCR. These are challenges that exist in the documents in general. So you have something called blackens, okay, and these white gray boxes, and this will hinder your, what do you say, if you see here the text is not properly visible at all. Okay, even I zoom, the text will not be visible properly. Okay, and your text can also be of low resolution. Okay, the scanner is of poor quality and it can be of low resolution. And suppose say sometimes your paper is not placed correctly and there can be some kind of a perspective distortion. Okay, and then you have a rotated text. Okay, the rotated text is there, and all the text processing softwares assume that the text is horizontal. Okay, you have to correct for this and then you have to do that. Okay, and you can have a skewed text also. I have told you in the morning session also, right? Here the letters are skewed. The V is not appearing as V. Okay, in the presence of this kind of a skew, if you give it to the text processing software, it will not infer the text correctly. Okay, so you should have a good text processing software in order to infer this skewed text. And you have a watermark also. This is a watermark called a draft, which is written onto this table. And if you want to infer the individual elements of the table, you have to remove this watermark first. Okay. So all these challenges, whatever are there, comes under pre-processing block. You have to remove these distortions first, and then only you can get into the programming part. Okay. You have steps in OCR. You have pre-processing of image. Okay, text localization and character segmentation, character recognition, post-processing. These are some of the steps in the OCR. You have to pre-process the image. You have to remove all these distortions if they are there. Okay, and then you have to understand where is the text is. For instance, in the traffic case scenario, you have captured an image. The police will be capturing thousands and thousands of image per day. Okay, and for them to sit and manually identify what is the license plate information and bill the person who has violated the traffic rules accordingly, then if they want to do that manually, it will be very laborious and the time consuming task. Okay, what's the best thing that you can do is you can use some kind of an OCR framework in order to identify the text first, okay, for which text localization is important. Okay, and character segmentation. After the text has been identified, you need to identify individual characters. And once you have segmented the characters, you need to know what that character is, whether it's A or B, whether it's a numerical. And once everything is done, you have to finally report the license plate number in the post-processing step. These are the fundamental steps in OCR. And if you want to use OCR for your in Python, okay, you have to install these packages. It's so free of cost. Again, as far as academic research is concerned, this is free of cost. You can download them and use it on Colab. Okay, Tesseract OCR and PyTesseract. So this is how you can install these packages: apt install Tesseract OCR and pip install PyTesseract. Okay, these are the two packages that you can install. Okay, this is how you will install: colon apt install Tesseract OCR, colon pip install PyTesseract. Okay, so if you click this, it will install automatically. Okay, if you want to do the same thing in your system, then it will be very difficult. Okay, I would highly recommend, if you are there are a lot of issues that will be there to install these packages on your Python environment. Okay, I would not suggest anyone to install this in their own Python environment. It is highly complicated, but rather if you have a slightly stable internet connection as well, you make the best use of Colab environment. Okay, let's read the text image over here. You have PyTesseract, import PyTesseract, and from PyTesseract I want to import the output. Okay, import shutil, import OS, import random. These are some of the packages which I am going to make use of it. Okay, and from PIL I am importing image. Okay, and defining something called box plot. Okay, so we'll be using all the elements which I have told, the Python programming elements over here. Okay, so here if you see, I'm creating a copy of the variable. Okay, and why I'm creating the copy of the variable? Can somebody answer on the text box? Anybody remembers? Why do you have to create a copy of the, to avoid overwriting? Correct, because Python operates on pass by reference. Okay, so I am creating the copy of the variable, and there is a PyTesseract function. Okay, and there is an image to PyTesseract. From PyTesseract library I am extracting this, I'm using this function called image to data. Okay, and I'm telling that I want the output in the dictionary format. Okay, this is a dictionary of bounding box information. Okay, here if you see, there is a field called text. Okay, and I'm counting the number of boxes first for every box. Okay, for every box, what essentially I'm doing over here is, okay, I'm getting the top left coordinate and top coordinate, right? So once I have this x and y coordinates and the width and the height of the box, okay, I can clearly draw the bounding boxes around each word. Okay, so how you can draw? You can use this if you have this information, x, y, and the width and the height. Okay, this x, y corresponds to the top left corner of the every bounding box. So this top left corner of this bounding box, top left corner of this bounding box, top left corner of this bounding box. So every bounding box have the top left corner, and this xy coordinates include the top left corner coordinate of your bounding box. And you also give the width and the height. You extract the width and the height information. So that also is given as a dictionary element. Okay, so I use this cv2.rectangle. Okay, cv2.rectangle. Okay, and if I use a cv2.rectangle, okay, what happens? Im underscore copy, okay, comma x comma y comma x plus w comma y plus h, and 0 255 0. I'm giving a color coding to the box. Okay, why do you think if I use 0 comma 255 comma 0, it produces a green bounding box? If I give a color code as 0 255 0, why do you think it produces a green color box? I didn't get you, Mohammed. Yeah, red and blue are zero. R and B component are zero. This RGB, because the colors are represented as RGB components. I am giving a hint that, okay, I want a green color bounding box, so 0 to 55 0. Okay, and if I want a red color bounding box, what should be the code here? If I want a red color bounding box, what should be the code? 00255? No, it's 25500. Okay, RGB. Yeah. Right. So I have two. This 2 indicates the width of the bounding box. Okay, this 2 indicates the width of the bounding box. Okay, let's try to see and have a red color bounding box for us. I have to attach the Google Drive first because I have resetted my runtime environment. The Google Drive is mounted. I'm changing the directory. It says an error at text. CB2 not defined. Import CB2. PLT not defined. Have a red color bounding boxes 25500. Right? If I want a blue color bounding box, you give the code as 00255. Okay, so this gives me the width. As I increase the width of the bounding box, it will increase the width basically. Okay, so this numpy I'm importing so that I have a numpy array. Okay, so it is also, if you have an array, something to be done in the array processing, then that is how it is done. Okay, so now what I'm trying to do over here is I'm adding some kind of a noise. Okay, you know salt and pepper noise, right? So you have a salt and pepper, you mix together, and randomly you just spread it across on a plain paper. Okay, you have white and the black spots. In the similar way, you will have something called salt and pepper noise. You can simulate this. Okay, you define a function. This is how you write this definition: def keyword, the function name, and the input parameters, colon. Okay, this colon is essential in your Python programs. Okay, here if you see at the end of for loop you have a colon, at the end of for loop you have a colon, at the end of if statement, elif statement, you will have a colons. Okay, so at the end of these constructs like for loop, if, elif, while, so definition of a function, all these things you should have a colon. Okay, and you should maintain an indentation of 4 spaces. Okay, so if you don't maintain these 4 spaces, then that means this output comes out outside this function, and all the statements which you want to define inside this function should have a minimum of 4 spaces. Okay, and I want these statements should come under these 2 for loops. So that's mean I'm giving 4 more additional spaces, 4 for this for loop and 4 for this for loop. Okay, so that is how you should count. Okay, if you have a difficulty, all that you have to do is a press tab. Okay, you will have 4 spaces available for you. I'm reading the textual image. Okay, and I'm using this sp underscore noise. I'm passing on to this image and giving this 0.05 and producing a noisy image, and I'm rewriting it. I'm showing this noisy image. Okay, this text noisy image. Okay, so the next thing what I'm doing over here is I'm passing it out to the my what do you say, the box plot function. Okay, and then And also I'm trying to extract by using this image to string. Okay, if you see the text here is identified as A8, this is the first time off. Okay, the text is not properly getting identified. This is what you have to note. Okay, the bounding boxes are also not correct. Okay, but with a clean image without the noise, you have a clear bounding boxes. Okay, of course, some bounding boxes are not exactly correct, but you have a clear bounding boxes drawn. The bounding box information is not extracted correctly when the image is noisy. So what I'm doing here is I'm using something called median blur. Okay, I'm using something called median blur, and then I'm using remove noise function in order to get the denoised image. Okay, this remove noise function, I'm using a median blur filter. I'm extracting the median at each and every pixel, and then I'm getting a denoised image. Once I have denoised image and pass it on to the PyTesseract function image to data, I'll be able to extract the text information correctly. Okay, so the next, another distortion. Let's see another distortion. I have a watermarked image now. Okay, if I have a watermarked image, this is a watermark which is written on this image, and if I want to extract the textual information, then it will be very, very difficult. Okay, watermarked image, you will have a textual information written. It will be very, very difficult actually. Okay, so this is the information this is the tabular information that is being extracted in the presence of watermark. Now I write a small logic. Okay, if I write a small logic, due to the lack of time, I'm not going through it in detail, but I write a small logic to remove it. Okay, and this image, if you see, this is a free of watermark, and at least the table structure is not correct, but at least the numbers and the words you are able to read it here. Okay, so that means you have to pre-process your images. Okay, you have to pre-process your images. Okay, in order for this text processing software to work well. Okay, text processing software to identify the bounding boxes or the textual information written correctly. Okay, you have to pre-process your image, whether it should be a denoising, whether it's a watermark removal or something else. Okay, you have to pre-process these images. Okay, so this is all about Python programming part. Okay, you have seen the fundamental programming elements. Okay, which is nothing but Python collections, lists, tuples. Okay, you have seen sets. Okay, I have not shown any demos with sets and tuples, but dictionary and the lists are the most two important. And you have a NumPy arrays. Okay, you use a NumPy arrays for image processing. Okay, I've shown how to do slicing, different operations with lists. What is list comprehensions? How to write for loops? Okay, how to write if statement. Okay, I have also shown that the functions in Python are operated on pass by reference. So you need to use something called a copy function in order to make a copy and then work on it, and so that the overwriting is not there. Okay, we have also taken a look at that. You have all these images needs specific pre-processing. The text processing software can be installed by using PyTesseract and Tesseract OCR, right? These images are this pre-processing has to be done before you feed it to before you feed it to text processing software. Okay, and it can be noise removal, or for that sake, any of these distortions which are mentioned over here. Okay, so you have all the distortions which are mentioned over here. Any of these distortions, first you have to remove them, work towards it. Okay, and before you feed it to your text processing software. So this is all about Python programming. It's very, very simple. All that you have to do is you have to get into writing small pieces of codes. Okay, and if somebody is interested, if you need an access to these Colab notebooks, okay, if you need an access to these Colab notebooks, which I have shown you today, I would recommend you to I will recommend you to drop an email to me, okay, requesting for this Colab notebooks, so that I can give you permission to access this Colab notebooks. Okay, that will be given only on the request basis. So I will not share it publicly. I will share it only to the people who are requesting it. Okay. So this is all about, this is a Colab environment. This is a beautiful environment, right? So, and somebody was asking about what is the difference between, I wanted to show some more demos, but I think it makes sense for me to show a couple of more works that I did rather than focusing on this. Okay, so some of the parallel processing and tensor operations I wanted to show. So this is a PyCharm environment, so you can run your programs here as well. Okay, but the reason I have chosen Colab is I want to show you what kind of resources that are coming up with free Colab notebooks. Okay, this is the PyCharm environment, and then once what do you say? So there is a file and then settings. Okay, if you go to the settings, you will have all the informations of what are the different packages that are already installed over here. Suppose say here if you see, it's coming as a loading. Right, there are multiple packages which you can install. There is a plus sign, right? So whatever package you want to install here, you can install it. Okay, but you will not have an access to the GPU, because GPU, if it is installed in your laptop or a workstation which you are using, that's perfectly fine. Else you will not have an access to the GPU from this PyCharm environment. Okay, so I would highly recommend you to get started comfortable with Colab, because that is what people are expecting you to get comfortable at. Okay, and so these are the different Python programming things, and if you have any specific queries, then we can take it up. But let me talk about what do you say, one of the recent publications that we did. Okay, and so this was a publication which we published in the CVPR conference. Okay, and along with my colleagues Akshaya, Jay, and Bala. So one of the motivation here was to detect the actions. Okay, we want to detect the actions, so that given a video, how do we detect that actions? Okay, so there will be multiple data sets. Okay, so these data sets are available publicly. You can just download them and build your own architectures. Okay, and environments like Colab will definitely help, because you won't be having some spaces like 100 GB or 200 GB on your hard disk sometimes. Okay, so all that you can do here is you can just download onto your Google Drive and then connect it to buy that space on Google Drive and then connect it to your Colab environment. Okay, and so we have to recognize, given these, to recognize these actions. Okay, the actions can be at different levels. There will be a pose you have to verify, whether a person is standing, catching an object, listening to other person, right? So standing and talking to a person, walking, holding an object. So these are different things that you have to explore. So you can sometimes what happens is, even though action is something which you can infer by seeing a video, sometimes by choosing a single frame also you can identify few actions. Something like sitting, somebody is standing. Okay, you need not have a video for it. You can just observe it by using a single frame and then do it. There are few actions which you can identify only if you have a few small few set of frames, a short segment of frames. Okay, talking or listening, opening door or closing door, right? So but for few actions, okay, you need long set of frames to capture the actions. Okay, something like taking an object or giving an object. It spans across multiple seconds. It's a 1 or 2 seconds video, or more than 4 or 5 seconds video sometimes is needed. Okay, to identify action. So what we did was we came up with some novel deep learning architecture which takes inputs as the input video, okay, and then infers what kind of an action it is. Okay, and we are able to show that with over the state of the art, we are able to show with an improvement of this thing. The state of the art was 30.7. A frame MAP is the measure that is used. Okay, and we are able to show that it's 31.4. Even though it's minor, it's very, very significant, because that's very tough data set. Even a minor improvement is considered a great accomplishment. Okay, this, if you see here, the state of the art was 75 in for one of the approaches, and we were able to get 82.4. And for video MAP, 71 to 84, 82 to 87, 87 to 78, and right. So at one specific control, I think it's wrongly printed. It's 87.15. And we have an improvement, a lot of improvement in identifying the action. So UCF 101D dataset, it's freely available, and AVIA dataset is also freely available. ActivityNet, there is another dataset which is freely available. Okay, so this is one of the work which I wanted to show. Also, there is IASC, TCLs in collaboration with IASC, they did one small project. Okay, I'll show that also so that you are aware of it.
The progress made by Team Indian Institute of Science and Tata Consultancy Services towards Mohammed bin Zayed International Robotics Challenge 2020 is demonstrated in this video. Challenge 1 is to grab a ball from a target drone moving in a figure of 8. The hardware used for the same include DJI Matrix 100, GA3 as our own UAVs, DJI Mavic Pro, DJI Phantom 4 as target UAVs, and a variety of sensors. Our approach. The UAVs will map the arena to detect the dropping and landing zones and also the target drone with the ball. They then track, grab, and drop the ball before landing. The subtasks associated with our approach include autonomous takeoff and landing. The UAV employs visual clues to achieve accurate landing at the specified location. Detection of drop zone and landing zone. The UAVs map the arena in a predetermined pattern. They then detect the dropping and landing locations with the aid of onboard cameras. Drone and ball detection using vision. The target UAV and the ball are detected using machine learning algorithms assisted by vision sensors. Visual surveying of the ball. The target drone with the ball moves in a figure of 8 in an arena of 100 by 30 meters. Our UAV detects and tracks the ball using an onboard camera. Ball grabbing. The UAV autonomously detects and tracks a stationary ball using visual information. The ball is grabbed using a manipulator designed and manufactured exclusively for this task. Challenge 2 is to build a structure using 3 UAVs and 1 UGV. This requires the vehicles to pick the bricks and place them in a predefined sequence. The hardware used are DJI S900 UAV and a UGV designed, developed, and manufactured in-house. This uses a UR5 manipulator arm. A host of other sensors are also employed. Our approach: the vehicles detect brick piles of different colors and approach them in a coordinated fashion. They pick the bricks either on their own or in cooperation with another. The bricks are precisely placed to build the structure using specially designed manipulators. Brick detection. Stereo and monocular vision are employed to detect the bricks. Additionally, the visual information obtained from monocular camera is used to estimate pose and depth of the brick. Brick pick and place using UGV. This task is initially simulated in Casino. The simulation utilizes the models of an indigenously developed UGV and the UR5 manipulator arm. The UGV navigates in an arena where there are four different brick piles.